This is Jill Hurston, a marketing director at Synerzip. Welcome to our webinar today. I'd like to introduce Sabu Sankara. He is our VP of Software Services. He will be moderating today's webinar. Sabu, over to you.
All right. Thanks, Jill. This is your moderator, Sabu Sankara. So good morning, good afternoon, good evening, depending on your location, wherever you are. And welcome everyone for this monthly webinar series. We are excited to have you all attend this webinar. Thank you for taking time from your busy schedule to attend this webinar on this important topic. And I promise that your time investment will be worth it. So the topic on hand today is Topgrading UX with Microservices plus DevOps. And now on to introducing our speaker, Vinayak Joglekar. Vinayak Joglekar is the co-founder and Chief Technology Officer of Synerzip, India office based in Pune. He has extensive experience in software development. He co-founded Synerzip 15 years ago to help drive innovation and bring agile approach to software development for Synerzip customers. Vinayak is a hands-on practitioner of agile and lean techniques and is a regular attendee and speaker at these annual conferences. His passion is to hire the right talent, put together focused software development teams to take on challenges of software product development in cutting-edge technologies for Synerzip customers. So with that, over to you, Vinayak.
Thanks, Subbu.
So let's talk about how Synerzip builds products and product features that are so delightful that they captivate the end users. So let's step back and see where we are today. This 2019 and 2 decades into the millennium, we are pretty good at building software that works. We know our Agile, we know our Lean, we do Scrum, we do sprints, TDD, BDD, continuous integration and continuous delivery, DevSecOps, Kanban, and what have you. So all these processes and tools have enabled us to be able to build software to any requirement that is stated. So if someone tells me or us what he or she wants, we can build that software. But that is just half the solution to the problem, because we don't really know what the end user wants, and usually what he says is not what he wants, and what he wants is not what he needs. So being able to deliver something after we know what is required is important, but it is not completely fulfilling the business objective of giving the user what he really wants and needs. So let's see why this. So let's delve a little bit why the end user is not getting what he wants and why. And the symptom of it is that most software is not used. Is it because it's not relevant, or is it because it's not simple enough, or is it not friendly or usable or needed? Is it not cheap enough or quick enough or safe enough? Maybe all of these. So we need to think hard as to why most software is not used. And let's take a look at some of the numbers that are published. So we did a little bit of research to find out that typically this is a dated research, 2016 research, but things haven't changed much. They might have become worse. So this is about apps. So when a user downloads mobile apps, within the first month, 64% of them abandon it, and by the third month it's 80%. So, and I can imagine, because I have so many apps which I have downloaded which I have never used. So I can imagine how the magnitude of the problem of abandonment of apps. Similar survey done even before, it's even dated way before, but still things might not have been any different. I could not find something which is more recent. This is about use of features. So what this survey says is that 45% of features are never used and 19% of them are rarely used. And I can believe it. So, it's not a small problem you're talking about. If you see the dollar numbers, it's a lot of money that is being wasted here. It's like bridges, or a bridge that is never used, or a car that is never driven, or a device that is hardly used. So how do we get users to use what we are building? So game designers and people who build software that is getting people hooked to the games, they have done a lot of this thinking. and let's take a look at how they do it. So the basic idea here, and these are two pictures that you see in front of you. The one on the left is by Neil in his famous book called The Hook. So in this, a user gets involved or it starts using your application with a trigger, which could be an external or internal trigger, depending on an external trigger could be an email and an internal trigger could be, you're hungry. So you start using an app and then you take some action, and this action is so easy, so smooth, and so intuitive that you are able to take that without much effort. So once you take that action, you get a variable reward, and the reward is variable, and that is important because if you get the same reward for same action, often you'll find that users get bored. So if you have variable reward, that keeps the user engaged and interested is what. So there was an experiment called the Skinner box experiment, which was conducted, and based on the results of that experiment, it's the dopamine hit that you get in anticipation of the reward and not after you get the reward. So sure of getting a reward no matter what, you will not have that anticipation. So the anticipation is when you're not sure, and then that's when this increase in adrenaline level comes. So that is what gets people hooked. And finally, when they go through these type of action reward kind of cycles very often, they end up investing a lot of their learning or a lot of their data or a lot of their connections, such as friends connections, and they build some level of trust in the application, and all that can be called as investment, which prevents a user from moving away from the application. Even if he were to or she were to see a better app there in the market, he would not move away because he or she would have all the friends and connections and photos and the learning that one has in that invested. So that's the hook model. On the right hand side is another model by the game thinking expert Amy Jo Kim, which is similar. So you start with triggers. It could be again situational, external, internal, which I have described earlier. Then it gets you involved in an engaging activity. So this is an action which is very engaging, which kind of gets the user to fully focus his or her attention, and then you get a feedback. So the reward here is the feedback and progress that you see that you're making. So the progress part is very important because the thinking that Amy has is about, what gets the user really engaged is pleasure, or that he or she derives out of learning. And there are other thinkers here, including someone who's written a book called The Theory of Fun. So in this book also they have discovered that the fun comes out of learning, and that's what keeps the user engaged. So when you have a more complex game that is being mastered by a user, that gives him some level of kick of having cracked a higher level or a more level, a more difficult situation. So the same thing, happens even in, you can build that into your application where you give the benefit to the user of, or you give the ability to the user to discover new and more complex features, and in the process the user learns and becomes a master user of the application. And once that happens, that is the investment. So the loop completes when the user actually goes to the next level, where he makes not only himself smarter, but also the application becomes smarter, because now application knows the user better, and he is able to configure the application or add some data to the application or value to the application, which is the investment that makes the application and the user smarter to give bigger value and higher value outcomes. So these are the two models, and then we at Synergip had further evolved thinking as to how we will utilize these models to build engaging software. So we have a similar loop here. The first loop in our thinking is effort. So you have some effort that you have to take to use the product, and it should be so minimal, it should be so smooth and easy and intuitive that every visitor would want to become a user, and then he or she receives such a valuable variable reward. Again, I don't need to talk about why it is variable. It will make the user return for more, and when that becomes a habit, repeated user use will form a habit, and it would end up having the user store a lot of data, photos, comments, reviews, ratings, and connections, etc. in your application, which in turn results in commitment. So it's the learning to use the application. It is also the application becoming smarter because of the data that has been shared with the application, and the application uses artificial intelligence and machine learning to learn from that data to become, to provide or to predict what the user wants, even before the user says it, or the user tells, or user acts in a certain way. It is predicting ahead of time because you already have a pattern built into the data that has got accumulated over a period or compiled over a period of time. So this is the virtuous circle that we are trying to build, so that every visitor becomes a user, every user becomes a repeat user, and no one ever unsubscribes. So that's the vision with which we are trying to build applications. So much for how to build applications, but there are a lot of these assumptions that are underlying this, and we need to have these assumptions or these hypotheses validated. So we have to follow hypothesis driven development. So it's nothing but the lean learn, build, and measure cycle, where you start with an experiment. First you document the assumptions hypothesis you have. So we'll see some practical example there. Then you formulate hypothesis, you design the experiment, you develop the experiment, then you run the experiment, and then you synthesize and analyze and learn from it, and then move to the next set of assumptions. So that's the hypothesis driven development cycle. So there are hypotheses that need to be validated by iteratively building and field testing features and functionality to get the desired response or behavior from the end user. So this is the cycle that we talked about. So let's see in our way of, so we talked about effort, reward, habit, and commitment in the previous slide. So what are the hypotheses we are talking about? So any hypothesis can be put on a card, the green colored card that you see. This is courtesy ThoughtWorks, which says the capability, that what is the capability that you're trying to build, and what will be the outcome if you build that capability, and when will you know, and how will you know that you have really got the desired outcome? What's the measure of success? So what is the measurable signal that you see outward to know that you have really succeeded? So there are a number of these hypotheses. That the first hypothesis is that the user interface will be relevant and quick and intuitive enough for the visitor to become a user, right? So that's the capability is quick and intuitive UI, the outcome is minimum effort, and the measurable signal is a visitor becoming a user. Similarly, there's a hypothesis that the value delivered is highly rewarding and promises to be even more so for a user to return and try again. So how will you measure that? By seeing that the user becomes a repeat user. So the capability of increasing value per visit with every visit is realized by the user. The outcome is he gets a very highly rewarding experience, but the measurable signal is the user becoming a repeat user. And then there are these complex features that you have built into the product so that the user will be able to get empowered by learning these features. And the outcome is that he will be empowered, and the measurable signal here is that he becomes a habitual user because he has now mastered these complex features, and that really makes him a power user. Lastly, the capability of artificial intelligence and machine learning makes the app smarter by the data that is being shared by the user over these multiple cycles of use, and thus the user ends up becoming a permanent user, and such a user will never unsubscribe. So these are various hypotheses that we talked about that need to be validated using hypothesis driven development. The hypothesis that the user will remain committed, the hypothesis that AI and algorithms will deliver the increasing value that we are talking about. So to get these hypotheses validated, you need to use certain tools and techniques, and the remaining part of the presentation we are going to talk about what are those techniques that we need to use for doing hypothesis driven development, which also itself is a technique, just such as what you see in the diagram on the right hand side, where you have a user interface, then you have a middleware business layer, and then you have the data at the back end. That monolithic architecture makes it really hard for you to do hypothesis driven development, because not everyone is Facebook. Like Facebook is a monolith, but they have several hundred releases every day, but for which they have their own tool set, which they have hundreds or thousands of developers working on those. Not everyone can have that luxury. So by and large, those who are having monolithic applications take maybe a month or maybe 2 weeks, before which they can't release more frequently. I mean, their frequency of release can at best be 2 weeks or a month. So with such low frequency of releases, you end up bundling too many features into one release. So when you see the end user behavior, you cannot isolate the effect of a feature on the end user behavior, because there are several features that have gone into a release. Also, adding or removing a feature takes a lot of work, because these are typically horizontally sliced features. So you don't have a functional feature which has its own UI, its own business layer, and its own data that can be segregated. There's a lot of dependency within each layer. So you may be able to add few columns to a schema, but to have that and then have the business layer change and also UI change in response to that is hard. So it's the basic problem with the horizontally sliced architecture. So with the size of the monolith growing, it becomes harder and harder as it gets bigger and bigger. Also, making changes when you have so many dependencies, you don't know, by making a change, are you stepping on toes? It may result in regression, and you have to do regression, end-to-end regression testing. Even for one small change, you have to do several hours of regression testing to ensure that the change that you just made is not breaking something. So the problem that we have is solved partially by the likes of Facebook, by doing continuous delivery using DevOps. So you start with continuous integration. So you check in a small piece of code, and as you can see in step number 1 to 3, you build that code as soon as you check in using continuous integration tools like Jenkins or Circle CI or Bamboo or what have you. Then at step number 4, as you can see here, you test the code using automated regression testing. You ensure that whatever you have checked in hasn't resulted in any issues. Wonderful. Then at step number 5 and 6, you have built infrastructure as code. So you release it and deploy it with a push button deployment which is fully automated, and it becomes available to the world, whatever you have built, because it's all automatic, right? So you have the infrastructure is built and the code is pushed into the infrastructure, all by running a program or a code or a script, if you will. And finally, this becomes broadly available to the world because it's on a cloud-based distributed system, and you have many analytics tools that would be, in addition to things which are very popular such as Google Analytics, there are many other tools as well that make observability and traceability possible for you to get a lot of insight into the way the user is behaving in response to the new feature that you've just built. It's a wonderful tool or set of tools that have made it possible for us to have continuous deployments in succession. Might sound a bit utopian, because in reality, if you have dealt with large applications, making small changes to large applications often is not economical because it takes too long. So though theoretically it is possible, practically it is hard. That's because monolithic enterprise applications have long regression testing cycles. So even though it is automated, that automated script itself may take several hours of running, and even if it fails in the middle, then you have to start from the beginning again, or you have to write idempotent way of testing, where the test will start from where it left, where it broke. Continuous delivery pipelines are hardly tested because your dev, test and prod environments are not identical, because you have a huge monolith which requires a lot of resources, and you can't have those many resources available in dev, test and prod environment. It will become resource heavy and it will cost a lot. So you end up having a environment which is scaled down environment, maybe a laptop for your development environment, maybe Some staging environment is where you do QA or testing, and then you have the full-fledged, fully equipped production environment. So if you use a particular deployment script or instructions, that is can't be the same for all three. So one of the things that happens here is that if the script for production is different, or the pipeline for the production deployment is different than the deployment pipeline in dev or in test, then you're not very sure that all three pipelines are doing the same thing. In fact, they are not. And as a result, what happens is the frequency at which you get to test the deployment pipeline is less, because you're not, if it was the same pipeline that you had used for all three environments, by the time your application reached production, you would have used it many times over in development and test, but that's not what is happening here. When it reaches production, it is the first time that this new set of features and new set of artifacts are being pushed into production using a pipeline which is never tested. So that is the risk that we have, and that's what makes it harder. And of course, you don't have feature toggles, feature rollback, and things that are hard to implement. I mean, you can do it, but rolling back, moving backwards in time with a large monolithic application is easier said than done. So the solution is containerized microservices. So just shrink your application to a microservice, and that's what makes it easy for you to build, test, and deploy it in a short, quick iteration using the same pipeline, because now you're not having a very resource heavy environment. In fact, your environment is a single container, or maybe a bunch of containers that are contained in a pod on a Kubernetes deployment. So one feature can be deployed at a time and built and deployed independently, because that feature has its own backend, own middleware, and an own front end. So that's it's like a very mini micro kind of application that can be deployed in isolation into a particular Docker container, if you will. So also, the dev, test, and production environments are identically configured because all three run inside a Docker container. Feature toggles, canary releases, Bruggen deployments are for hypothesis testing. We'll see a little bit of that later. It's easy to build these things because you have packages or libraries like Spring Cloud which have these built in. So it has become like, you just have to say that, okay, I want to do a feature toggle, and then there is a recipe that is available in literature that you can just implement. Also, integration and regression testing is limited to one microservice, so it doesn't take too long. It may take a minute at the most to test the entire microservice end to end in an automated way. So it's much easier than waiting for a few hours. So it is possible for you to make this small product increment, which is one feature, as a microservice, and then deploy it in production several times. You can do such small deployments several times or several hundred times in a day. So that's the direction in which Synerzip and our developers are going. So once again, to look at the solution, these product increments go through these three stages that you can see here. So you have the first continuous integration stage, in which the code quality is tested using static analysis tools. Performance testing, unit testing, container scanning, and dependency scanning is what you do in the verification stage. Then you package what you have verified, your code, into a container registry or a Maven repository or an NPM registry. Typically, you might be deploying or packaging them in container registries such as Docker Hub. These could be Docker images being put into Docker Hub, and then it is released into production. So there you may be using sophisticated tools like GitLab pages or Canary or feature flags. And we will see the difference between continuous delivery and continuous deployment. Deployment is when it finds itself in the hands of the end user. Delivery is when it becomes available, but it's not yet being released to the open to the entire user population. So in continuous deployment, again, we use deploy boards, auto deploy, push button deployment, and GitLab releases. So that is the difference between, these are the three stages, the verify, package, and release stage. So we'll see a little bit more into that in this build here. So continuous delivery is depicted by black arrows, and continuous deployment is depicted by red arrows. And then you start with the development. Developer checks in the code into commit stage tests, which are carried out by him on his laptop before checking the code into the repository, right? I mean, he will be running some unit tests on his own laptop. It reaches the repository, which not only consists this code, but also it consists of Docker files and config maps, right? So we marry the code and the environment, or the configuration for the environment. The way your Docker environment will look like, in which your code is running, is also put in the form of scripts or Docker files or config maps, and that is checked in along with your code, because of which you'll never have a situation where you're unsure of when something goes wrong. Is it because of the environment? Because you have made no, you just created the environment specially for the particular release, and you already know that this release works in that environment. Once that happens, you have the next stage wherein Jenkins will get triggered, and in Jenkins you'll have a test container that will automatically be brought up, and that test container will run tests like whether the API contracts are valid, whether for a JSON you are getting the desired JSON output. Also, it will conduct certain unit tests, and then this will spit out the Docker files, or rather the Docker images, and then put them in Docker Hub repository. And you will have several versions of those stored in a repository. So at a time you may have a version that is deployed in production, a version that is in test, and a version that is in development, right? So you may have the latest version 3 may be in development, version 2 may be in testing, and version 1 may be in production. How you push these into is by describing the environment and the application, what resources it needs in terms of Docker images in a Kubernetes deployment. So you have a Kubernetes deployment which is descriptive. So it is the end state that you describe in a Kubernetes deployment, and it picks up the right images and puts them in pods, and spins up those pods. So that is what is automated way of deploying in a distributed application, which consists of several microservices. So this is a Kubernetes container orchestration engine, which takes the Kubernetes deployment and creates the needed environment and deploys the Docker containers in that environment, first to development environment, and then you conduct some API tests, and then if you find those tests are being passed, well and good, you will promote it to test environment. If not, you'll file bugs and go back to the development stage and try to fix those bugs. If it gets promoted to test, again you will conduct user acceptance testing, manual testing, performance and security testing, and then you'll see the reports. If everything is okay, it will get promoted to production. If there are bugs, again it will go back to development. Finally, in production, it will have some release tests, like some sanity tests that are carried in an automated way, and if it passes all those tests, well and good. If not, then if it fails, then it will be rolled back. If it passes, then it is exposed to the market for product market validation. Users will start using it. You'll start seeing whether they are behaving the way you had expected them to behave, using various tools which give you analytics information. So Optimizely or Google Analytics are some of those. And based on that, you will validate whether your hypothesis is true or false, or needs to be tweaked, or your application feature needs to be tweaked. Whatever be the outcome, there's a lot of learning that ends up giving you the next set of features that are prioritized in your backlog, and using that your development cycle continues. So the first thing that we need to look at is what are the tools and what are the different frameworks, as well as what are the different types of environments that are instrumental in building these continuously integrated and continuously deployed containerized microservices. So what makes it possible? So far we have only talked about the way to do it, but getting down to a little bit more detail, we'll be seeing what Synerzip does to make all this possible. So the first thing is, the environment in which we operate is entirely cloud-based. So infrastructure as a service is a given. So whether it is spinning up new nodes or new clusters of nodes, or putting a Kubernetes framework or orchestration on top of that, and spinning up new containers and pods within that. All this is entirely managed by writing script and code. There is no physical device that we are talking about here. So these are the three main cloud providers that we are familiar with: Amazon Web Services, Microsoft Azure, and Google Cloud Platform. And what is common between all three is that all three support Kubernetes and Docker. So on all these three platforms, we have containers, so mainly Docker containers that are running on top of Kubernetes. So Kubernetes has been the biggest change that we have seen in recent times, which has made possible for us to write applications on one type of cloud provider, such as, let's say, AWS, and then migrating that application to Azure or Google Cloud. So it's been possible because once you have a environment which can accept Docker containers in the pods and then run from that, you're pretty much isolated and you pretty much don't need to know where your application is running. Of course, there are many managed services which are available on AWS, and those are not available elsewhere, and vice versa. So, if your application is using those managed services, then in that case, of course, you'll have to make some changes. But if you're entirely contained within the Docker containers, and if your application is running entirely within that, then you don't really have to bother. In addition to Docker, the other type of containers, there are other containers as well as Rocket, and this is just for your information. So there is a Docker Swarm, which is an equivalent orchestration framework like Kubernetes, but it's not as popular. So mostly you'll find individuals and also developers within Synerzip using Kubernetes, unless it's a requirement from the customer side that we need to use other container orchestration frameworks. For continuous integration and continuous delivery, we are using Bamboo, Circle CI, CodeShip, or Jenkins. Jenkins, of course, being the most popular of the tools. We already looked at container orchestration and containerization. So Mesosphere is another one. Rancher is another one, which we didn't mention. We already touched upon Kubernetes and Swarm and Docker. For provisioning, we use Chef, Puppet, Ansible, SaltStack, and AWS. So these are some of the provisioning tools which allow us to automate deployments. For the cloud providers, we already touched upon. In addition to GCP, Azure, and AWS, we have teams that are familiar with OpenStack and Alibaba Cloud. As we've seen that machine learning and natural language processing form an important part of building applications that become smarter with use, which is what ends up making the users more committed, getting total commitment from the users, and to ensure that there is a lock-in, and correspondingly there is a barrier to entry for a competitive application by making your application smarter. So these are some of the machine learning and natural language processing libraries that, of course, there are many. This is just a sample, whether it is Gate or GenSim. GenSim is for creating models of word vectors. Gate is natural language processing for text processing. TensorFlow is for neural networks, and IBM Watson is a natural language processing library. And again, NLTK is natural language processing library within Python, and Python has its own set of machine learning and natural language processing libraries. So these are just representative, and there are many more tools and libraries that are being used at Synerzip to make applications smarter with every use. Data is also important because you can't do machine learning without data, and also visualizing the data and making good looking reports is important. So we use Looker and Tableau extensively. Kibana is being used for logging data and traceability. Zipkin is also used for similar purpose. And of course, there are traditional tools like Power BI and SSRS, SSIS, which are reporting and integration tools. For logging and collection, we use Datadog, Splunk. These are some of the popular tools. For parallel processing, so concurrent processing is the right word. Use Hadoop, Apex, Apache Spark, and Google BigQuery. Apache Spark being the most prominent one on these. The languages for data manipulation, Python is by far the most popular one, but we also have some teams that use R and Scala. And for data warehousing solutions, we use Snowflake, extensively. We also use Amazon Redshift in some cases. Hive was being used, it was popular, today not so popular. And Cassandra is another one which we don't use much. For tracing, logging and telemetry, this is important for ensuring health of the application and microservices that are running. So Prometheus, New Relic, Zipkin, and more recently, we have started using service mesh. So where you have a Envoy sidecar sitting by the side of every pod in a Kubernetes deployment, and this sidecar sends sensor data. It senses log data from each of the pods, and then it sends it, and it's collected centrally and processed by Istio. A similar solution is also Linkerd is another similar solution. So you have a data layer and a control layer kind of situation in the service mesh. So that's the way things are going to move forward with, multiple technologies can be combined together. So you have some applications running containers, some applications running Lambda kind of serverless functions, and then there are some that are using different languages like Node or Python or Spring. So to bring it all together, you require service mesh such as this. Users, the way they behave is something that needs to be monitored. If you ask a user, he won't be able to tell, but observing the user from behind the scene is much more helpful. So we use Google Analytics, of course, that's the most popular one, but there are also teams that use Mixpanel, Optimized, and Hotjar. So these are all tools for monitoring metrics that are capturing user behavior. To make the user experience more engaging and also to make it more look and feel wise easy to use, we have front-end libraries, React being the most popular one, Angular is the next, and then of course we have other libraries like EXTJS and Vue.js and PWA, which are PWA and Vue.js are promising. We might see more of those in future. Backbone and EXTJS have been around for some time, and React Native and Ionic are libraries which can be used on mobile phones. So cross-platform mobile implementations across different platforms like Android and iOS is possible using React Native and Ionic. And these are some of the mobile operating systems: iOS, Android, Xamarin. So, and Cordova, of course, it is again a cross-platform implementation that our teams are familiar with. All this needs to be tested using test automation, and as we already seen, that's a prerequisite for making continuous integration and continuous delivery possible, because unless what you're building is passing all the tests, it can't be deployed, and you can't wait for the tests to be manually executed. So automation is of paramount importance. So unit tests using JUnit, NUnit, and also Cucumber, which is behavior-driven testing framework. Load testing using JMeter, mobile tests using Appium and Robotium. Because there are other tools which are not so popular. I'm just naming those which are popular, and end-to-end testing using Jasmine or Protractor or JBehave. Sikuli is a specialized end-to-end testing tool where you can't really have any controls that are sensed by other frameworks such as Selenium. So then you use Sikuli for which is an image-based testing tool. And of course, it's not mentioned here, but Selenium is the most popular one that we use across all web-based applications. So you'll feel that, if you have all the tools and if you have this way of building software, that's the silver bullet, that you would end up building applications that are so good that every visitor will become a user, and every user will become a repeat user, and no user will ever unsubscribe. No, it's not just these things. It takes a team. It takes developers, QA, Scrum Masters, product owners, user experience designers, DevOps, and everybody in the team working together as a team. So having a cross-functional team that is, as you see in this picture, standing together and really working together as a team is what it takes, more than the processes and tools that I described before. What energizes the team is the feedback that comes from the end users. So there is nothing more satisfying for an engineer to see that his work is being used by an end user. So when there is data that shows behavior that is contrary to what is expected, the engineer should get immediate information and then they should apply their minds as to why the user is not behaving as expected. And that's where there's a lot of internal discussion that happens between different individuals within the team, be it the product owner who has designed the particular feature with the user experience designer who's given the initial thought and done the research, with the developer who's actually built it, and with the QA who has tested it, and the DevOps person who's actually deployed it and seeing the logs, and he's seeing the actual end user behavior and reporting it back to everyone. So all these individuals are important parts of this story, where having all the instrumentation and telemetry and doing all the research and forming all the hypotheses and getting them validated, all this is theory, but in practice, unless these people talk to each other and they put their heads together, you're not going to get the desired results. So having a self-organizing cross-functional team which has all these roles that I just described is of highest importance to deliver these applications which are so engaging that every user, every visitor will become a user, and every user will become a repeat user, and no user will ever unsubscribe. So with that, let's take some questions if there are any. Thank you very much.
Sure. Very good. Thanks, Vinayak. Thanks for the insightful presentation. You captured everything from requirements to releases, multiple releases, continuous releases, and deployments using various tools and techniques. So very, very good. So I encourage audience to type in their questions. We have some questions from the audience already, which we will go over. But I encourage everyone to type in their questions in the chat box, in the question box, and we will take it up after we go through a couple of slides giving overview of Synerzip. So Vinayak, if you can advance the slide, thank you. So I have a couple of slides that I'll go over about Synerzip. So we are your agile software co-development partner, and we are a 15-year-old company, as I said earlier in the webinar. We accelerate delivery, product delivery by putting together dedicated engineering teams, covering the technology skills and gaps, if any, of your in-house team. With the India-based software development center, there is a saving of over 50%. And also, we have technologists and professionals in the US to make it easy for your in-house team to collaborate and work on the products that you want to develop. So all in all, a very customer-oriented company that puts together teams that understand the technology architecture and drives the various product development phases. And in this slide, we are capturing a short representative customer list. In the last 15 years, we have served over 150 customers of all sizes, and we are doing some very good work on the backend platform using open source technologies, and of course doing good user experience on the application side, be it native application development on mobile and web, as well as using frameworks like React Native and Angular. So this is a sort of a 30,000-foot overview of Synerzip, and feel free to reach out to us anytime. So we'll take up a few questions that have come up, Vinayak, if that is fine with you.
Yes,
so,
I'm ready.
Great. So the first question is, can you do microservices without DevOps?
Yes, I mean, if you want to, you can. So doing microservices without DevOps is like, let me think through it. So you have to first, let's say you have a Docker container and you create a Docker image of a microservice, a few of these Docker images, and then using command line kind of tools, kubectl, you deploy that in Kubernetes, and and then you're ready to go. So that is one service. Then you have multiple services interacting. So there are several of these manual steps that you will have to do if you didn't have cloud based infrastructure, or you didn't have a tool such as which is like Ansible, which is allowing you to bunch together all these command lines and run those as a script that will do automatic deployment in an environment that is automatically created. So theoretically possible, but practically imagine there may be a few hundred services. So the problem with microservices and distributed application is that it's not small. The number, though each increment is a small increment, you're talking about a distributed application with maybe dozens of services that need to be deployed, right? So doing it manually is going to be error prone and tedious. So theoretically possible, but practically I don't see anyone doing it.
All right. Very good. Thank you. So the next question is, can you build an engaging UX, user experience, without continuous development, deployment?
Yeah, I mean, again, it's a good question that why do you require for building? I mean, if you're so good that you get it right the first time that you build, you design a user experience sitting in a design studio, and you build your software exactly to that specification, and the users love it and they use it. I mean, so possible. But in reality, no one gets it right in the first shot. You need to get feedback from the user, because end users are, they surprise you all the time. So you need to take a small product increment, and that is not possible to, as we saw. I mean, getting a small product increment without having a microservice is again very hard, because you cannot do it in a monolith. So again, theoretically, yes, you can do that if you don't need to validate your hypothesis. You just don't, your user's behavior is exactly what you want it to be, without you never go wrong in terms of what you hypothesize as to what the user behavior will be in response to your design. You're good, but that happens very, very rarely. So again, microservices give you the ability to test your hypothesis in the hands of the end user. So that is why it's important for us to have microservices.
Very good. Thanks. And you talked about design studio a little bit. You referenced. Can UX design be outsourced to a design studio? That possible, you think?
Yeah, it happens, but the typical approach of a design studio will be to have a design sprint, which is preceding your development sprints. So it becomes a design activity which is outside of the iterative hypothesis driven development cycles. So very often you have a design which comes in, which looks good, which is approved and blessed and all that, and then you start building, and then you discover things that cannot be built because of technical problems, or because of issues on production, or because it's not really getting what you want from the end user in terms of end user behavior. So then you can't go back to the design studio. I mean, generally these contracts end and there is a handover. So after the handoff, there may be a few things that change, but you can't keep going back. So I think it is like, and to compare, it is like, getting a prosthetic extension to, to your body than as compared to having it organically integrated. So if you do it within the iteration, it's like organically integrated. But if you have this outsourced, and if it precedes all the development iterations, then it is like a prosthetic extension.
Very good. Very good. So I think we are almost up against our time. So I want to highlight about the upcoming webinar. Vinayak, would you be able to please move to the next slide? Thank you. So this is the upcoming webinar. We are going to deal with the blockchain subject. It's very interesting. Blockchain, utilization of blockchain in clinical trials. That is coming up exactly 1 month from today. On October 24th. That's again at a different time, a little later time, 10 a.m. Pacific time, 1 p.m. Eastern time. And it will be presented by Mr. Ramarao, CEO and co-founder at BlockQ. And that's going to be a very interesting topic. And at Synerzip, we are deeply involved in blockchain projects, helping customers, showing value. And this is going to be one such topic where we'll go into the nuts and bolts of how blockchain is being used in a typical clinical trial scenario that we are helping this company. So with that, we are up against our time, and I want to thank everyone for taking time to attend this webinar, and hope you've gotten good value out of this one, and it is worthy of your time. And we will catch up in our next webinar series. And thank you, and we will sign off here. Take care.